Section 7.3 on multivariable linear systems. So these are just several pictures on what we're looking at when we're solving multivariable linear systems. Multivariable just means three variables, which is a plane in 3D. Okay, so the first picture shows three different planes that would intersect at one point. So their solution is that one point in the corner that they would have in common. The second picture is where three planes intersect on a line. So it could be any point on that line. So there are multiple solutions. There are actually infinite amount of solutions on that one line. The third picture is when the planes are the same plane and they would intersect at a plane. So that would be infinite solutions as well. Okay, then the last two pictures is where they don't have a solution at all. Where three planes intersect two at a time, they intersect two planes. The blue and the yellow intersects at a line, then the yellow and the pink at a line, and the pink and the blue at a line. But all three of them don't meet at the same place, so that would mean that they have no solution. And then the last one is when they are parallel planes, they also would not have a solution. Okay, so let's look at how we're going to solve these multivariable linear systems. In example 1, we're given three equations with variables x, y, and z, and they actually want us to determine whether the ordered triple is a solution. So on this one, we're just going to plug the ordered triple into each of these equations to see if it's a solution. It has to work in all three equations in order to be a solution to the system. So if I find one of the equations doesn't work, then I can stop working because it has to work in all three. So let's start with point A, -1, 0, 4. So when I plug that into the first equation, 3 times -1 minus 0 plus 4, I'm trying to see, does that equal 1? So this is -3 plus 4, which is equal to 1. So it works in the first equation. So I try it in the second. 2 times -1 minus 3 times 4, I'm trying to see, does that equal -14? So -2 minus 12 does equal -14. So we're good in the second equation. In the third, 5 times 0 plus 2 times 4, I'm trying to see, does that equal 8? And yes, 8 does equal 8. So since it is a solution to all three equations, it is a solution to the system. Same thing for point B. We're going to plug in the ordered triple 2, 0, -3 into all three to see if it's a solution or not. So first, 3 times 2 minus 0 plus a -3, I'm trying to see, does that equal 1? So this would be 6 minus 3, which does not equal 1. So I don't need to keep plugging into the other equations. It doesn't matter if it works in the other equations. It doesn't work in this one, so it doesn't work in the system of equations. Okay, so now we're going to solve the system by using back substitution in example 2. If you notice, they've given us one of the variables is equal to 4, z equals 4. So that makes it easier to solve this system. I can start substituting it into other equations to find out what x and y also equal. So I'm going to take what z equals and plug it into the second equation. So that's going to give me y plus 2 times 4 equals 6. So then y plus 8 equals 6, which would mean that y has to equal -2. So now that I know what y equals, I'm going to take y and z and plug them into the top equation. So 2x minus a -2 plus 5 times 4 equals 24. And we're going to solve for x. So 2x plus 2 plus 20 equals 24. 2x plus 22 equals 24. So that means 2x equals 2, and then x equals 1. So then we're going to write our answer as an ordered triple. So this is going to be 1, -2, 4 is the solution to this system. Okay, number 3, we're also going to solve, but this time they did not give us one of the values of a variable. So we're going to have to do a little bit more work on this one. But I noticed the third equation does not have a y. So I want to try to take the top two equations, 1 and 2, and I want to add them together to get the y's to cancel. So I'm going to take equations 1 and 2 and rewrite them. And I notice that one is a positive y and one is a negative y. So when I add these two equations together, I would have 3x, the y's cancel, plus 2z equals 9. Now, anytime I come up with a new equation, I'm going to number that equation, just so I can keep track of all the different equations that I come up with. So now I have equation 4 and equation 3 that both have x's and z's. So if I stack those up with each other, then I want to see, okay, what can I do to get either x or z to cancel with one of these equations? So what I'm going to do is multiply equation 4 times a -1, and that will get the x's to cancel out. So my equation 3 stays the same, 3x minus z equals 0. Equation 4 becomes -3x minus 2z equals -9. So when I add these together, this is a new equation 5. My x's cancel. I have -3z equals -9, which means that z equals 3. So now that I have a value for one of my variables, I can do the same thing that I did on example 2 and start substituting back into other equations. So I'm going to substitute z equals 3 into equation 3. 3x minus 3 equals 0, so 3x equals 3. So then x equals 1. So now I'm going to take x and z and plug them into one of the other original equations. And I always like to plug into the easiest one. So it looks like equation 1 would be nice. So I'm going to do 1 plus y plus 3 equals 6. So this will be y plus 4 equals 6, which means y equals 2. So my ordered triple is 1, 2, 3. This is the solution to this system. Okay, equation 4, or example 4, we've got 3 equations, same situation, but all of these equations have an x, y, and a z. So we're going to have to do several steps of elimination to try to go from 3 variables and 3 equations. We want to cancel one variable to get it down to 2 equations with 2 variables. Then I can cancel another variable and get it down to 1 equation with 1 variable. Then I can just back substitute. So you're just make a decision and decide what variable you want to cancel and go with it. So I'm going to start and look at equations 2 and 3 and rewrite those and determine what variable I want to cancel. So I'm going to get the z's to cancel, and in order to do that, I'm going to multiply one of the equations by -1. I'm just going to go ahead and do equation 3. So equation 2 is going to stay the same. Equation 3 is going to be -7x plus y minus 3z equals 0. So when I add these two equations, this is going to be a new equation 4. This is going to give me -2x minus y, z's cancel, equals 0. So now what I need to do is pick 2 other of the original equations and also get the z's to cancel. So I'm going to do equations 1 and 2. And I always like to rewrite them first so I can look at them and see what I need to do to the equations. So to get z's to cancel, I'm going to have to multiply something times both of these equations. So I'm going to multiply equation 1 times 3 and equation 2 times -5. And I went ahead and renumbered these equations 5 and 6. So 3 times equation 1 will give me 9x minus 15y plus 15z equals 3. And negative 5 times equation 2 will give me negative 25x plus 10y minus 15z equals 0. So now I'm going to add these two equations together. This is going to be equation 7. This is going to give me negative 16x minus 5y equals 3. So now my equations 4 and 7 both have x's and y's, so I want to put those together to see what I can cancel now. So equation 4 and 7, I want to multiply the top equation by negative 5, which will make the y's cancel. You could have also multiplied the top equation by negative 8, which would make the x's cancel. Either way, in the end, we should get the same answer. So negative 5 times equation 4 is going to give me 10x plus 5y equals 0. My equation 7 is going to stay the same. So when I add these together, I'm going to get negative 6 equals 3. Negative 6x equals 3. So then x would equal negative 1/2. So now that I know what x is, I can start substituting back into the other equations to find y and z. You always want to look for the simplest equation. So I'm going to plug negative 1/2 into x in equation 4. So negative 2 times negative 1/2 minus y equals 0 is going to give me 1 minus y equals 0, which will mean that y equals 1. Now that I know x and y, I'm going to plug back into one of the 3 original equations to find out z. So I'm going to plug into equation 1. 3 times negative 1/2 minus 5 times 1 plus 5z equals 1. So this will give me negative 3 over 2 minus 5 plus 5z equals 1. So because I don't want to work with this fraction here, let's multiply everything by 2 and it'll clear out the fraction. So that'll give me negative 3 minus 10 plus 10z equals 2. So then I can combine like terms. This will give me negative 13 plus 10z equals 2. So I add 13, and this will give me 10z equals 15. Divide by 10, and z will equal 15 over 10, which reduces to 3 over 2. So the solution to this system is going to be negative 1/2, 1, 3/2. Okay, number 5. Same thing. We're going to number our equations first, and we're going to make a decision as to what variable you think it would be easier to cancel out first. It really doesn't matter what order you go in. Just be consistent. The first time you got to cancel out the same variable back to back. So I'm going to look at equations 1 and 2. And I'm going to multiply equation 2 times negative 3, which will make the x's cancel out. So 3x minus 3y plus 6z equals 6 is the same as equation 1. Equation 2 times negative 3 will give me negative 3x minus 6y plus 3z equals negative 15. So when I add these together, my x's cancel, and I'll have negative 9y plus 9z equals negative 9. So now I need to pick 2 different equations and also get x's to cancel out. So I'm going to go with equations 2 and 3, and I'm going to multiply equation 2 times negative 5. That's going to give me negative 5x minus 10y plus 5z equals negative 25. Equation 3 is going to stay the same. So when I add these together, my x's are going to cancel. I'm going to get negative 18y plus 18z equals negative 18. So now my equation 5 and equation 7 both have y's and z's only. So we're going to put them together and see what we can do to cancel something out. So I'm going to multiply my top equation by negative 2 to get the y's to cancel. So equation 5 times negative 2 is going to be 18y minus 18z equals 18. And you may notice that when I add this together with equation 7, something funny is going to happen here. Everything cancels out in this equation. 0 equals 0. Now, in previous situations when we were dealing with just a two-variable system, when we got 0 equals 0, that meant infinite solutions. Well, in this situation, it's not necessarily infinite solutions. If you remember the picture from the beginning of the lesson, there are a couple of different options here for infinite solutions. That second picture where they all intersect on a line, it could be any point on that line. So it's not just any random point that I come up with as the same thing that we would have done if it was just an x and a y equation. So it's any point on that line, so there's some sort of relationship between those ordered pairs or the ordered triple. They have a relationship together. So anytime you get 0 equals 0 on a three-dimensional system like this is how we're going to proceed. We're going to say that one of the variables equals a letter, and it doesn't matter what you use. I'm going to start and I'm going to say z equals a. Z equals some number. I don't know what that number is, but z equals some number, and we're going to write the rest of the ordered triple in relationship to a. Okay, so it's just like if it was a number, we're going to back substitute. So I'm going to plug in z equals a into equation 5. So negative 9y plus 9a equals negative 9, and we're going to solve for y. So I'm going to subtract the 9a, so negative 9y equals negative 9a minus 9, and I'm going to divide everything by negative 9. So y equals a plus 1. So this means whatever z is, the y coordinate is always 1 more than that. It's always a plus 1. So now we need to find out what the relationship is with x. So I'm going to plug z and y into one of the original equations. I'm going to plug into equation 2. So this means x plus 2 times a plus 1 minus a equals 5. So we're going to distribute and collect like terms. X plus 2a plus 2 minus a equals 5. So this means x plus a plus 2 equals 5. I want x by itself, so x is going to equal negative a plus 3. So whatever z is, x is always negative that number plus 3. So I write them as an ordered triple. Negative a plus 3, comma a plus 1, comma a. It's not just any random numbers. These three have a relationship together, and this is their relationship.